So we've talked about how to add and subtract and multiply and divide rational functions. Today we're going to talk about solving rational equations, and then we're going to get into some inequalities. So the best way to do this, now remember, first of all, what is a rational equation? A rational equation is an equation that contains one or more rational expressions, right? Now, what we do is, first of all, we want to get rid of those pesky fractions, right? Those denominators. And the way we do that is we multiply by the least common denominator, and then we are able to get rid of the denominator, and then we could solve it just like any other algebraic equation, all right? So what we're going to do first is see if anything can be factored out. Okay, so factor if possible. All right. In this case, nothing can be factored, so we're good. The second is to state any restrictions. Now, restrictions are values that make the denominator 0. All right? So the 24 and the 4 were good because those are just constants. But look at the 3 minus x. What value of x would make that 0? 3. So the restriction is, you say x cannot equal to 3. Okay? Step number 3 is multiply by the LCD. And step number 4 is solve. Simplify and solve. All right? Okay, so in this problem, what is the LCD? Well, we're going to have a 24 times a 3 minus x. Okay? Every single term gets multiplied by 24, 3 minus x. Now, we're going to reduce everything that can get reduced. So in the first case, the 24 and the 24 go away. Here, the 3 minus x and the 3 minus x go away. And here, between the 4 and the 24, I have a 6 left in the numerator, right? So I'm just simplifying, I'm reducing, whatever you want to call it. Okay, so what do we have left? Here we have 5 times 3 minus x plus 2 times 24 equals 6 times 3 minus x. Yeah. Now, can you simplify in like, can you distribute in the same step and eliminate this step? Of course you can. This is an honors class, right? So basically this is going to be 15 minus 5x plus 48 is equal to 18 minus 6x, right? And now we solve this just like we would any other equation, right? So what is this going to be? 15 plus 48 is going to give us what? 63 minus 5x is equal to 18 minus 6x. So x is equal to 18 plus 63, so that's 81. And x is equal to 81. Any questions? And then the other thing is, okay, so check. Was 81 one of our restrictions? No, it wasn't. Our restriction was x cannot equal 3, so we're good on this one. Okay? Oh, it's 18 minus 63. Negative 45? I'm so sorry. It's negative 45. No wonder nobody was agreeing with me. Okay. All right. Any questions? All right, let's do the next one. So remember, first we're going to factor. Can we factor the denominator here? Yeah. It's x. It was x minus 9. Right? So how do we factor? X. Right. Okay, now, what are the restrictions? X cannot be 5 or 4. So we have to watch out for that. Now the LCD is x minus 5, x minus 4. So I multiply x minus 5, x minus 4, x minus 5, x minus 4, and so on and so forth. Okay, in the first fraction, which ones cancel? X minus 5s, and here I have the x minus 4s cancel. Everything cancels here. That's what we love, right? Okay, so if you don't mind, in this one, I'm gonna distribute in the same steps. So it'll be 8x minus 32. Now here I'm gonna distribute a negative 9. So minus 9x plus 45 is equal to 5. Okay? So 8x minus 9x is negative x. 45 minus 32 is 13. Negative x is equal to negative 8. So what's x? Or 8. Moving right along. Again, so why do we have to figure out what the restrictions are? Because sometimes by multiplying each side of an equation by the LCD, right, you're getting rid of the denominator. And when you do that, you're sort of artificially changing the problem. So you might be adding in solutions that would naturally not have been there. Okay, we call those extraneous solutions. Okay? Question? So let's factor this one. The middle will be x plus 3, x plus 5. So that's also the LCD, right? And I multiply everything by that. Okay, and you know what? Let's go ahead and factor this numerator as well. How much would that be? X, oh, you can't. That's right, even better. Okay, so let's see what we can cancel. The x plus 5s, everything here, and then the x plus 3s. Okay, now, here I have, I'm just going to write it out first and then distribute. So I have 2x times x plus 3 minus, in parentheses, I have this trinomial equal to 3 times x plus 5. So let's go ahead and distribute. 2x squared plus 6x minus x squared plus x plus 10 is 3x plus 15. Okay, let's combine terms. 2x squared minus x squared is x squared. 6x plus x, 7x, plus 10 is 3x plus 15. Let's move everything to the same side. We get x squared plus 4x minus 5 is equal to 0. Meanwhile, I never wrote the restrictions for this. What were the restrictions? Okay, now, can I factor this one? Yeah. Yeah, how? Yeah. So this is x plus 5 and x minus 1 equal to 0. So what's x? Negative 5 and x equals 1. But you're not allowed, we just said that negative 5 is a restriction. I'm not allowed to have x equals negative 5. I cross that out, and my only answer is x equals 1. So, and so on the test, for example, right? You solve this, you get x equals -5 and you get x equals 1. And if you write both answers in the answer space, you will have points taken off because you introduced a solution that's not supposed to be there. Does that make sense? Okay. All right, so let's do one more. Anything we can factor here? Right? So how can we factor that? Right? Okay, so restrictions. Right, x cannot be, now watch this notation, okay? Plus or minus 1, right? That's like saying x cannot be 1 or -1. I can condense it and just say plus or minus 1. So next time you're at that cool math party and you know, like you're going around saying all that stuff, okay? You might just get invited to the next party. Okay, so what am I going to multiply with? Right. And sorry if my z's look like 2's. I'll try to make them so they don't. Okay, so what can we cancel out from the first? Z plus 1, and from the second? And from the third?
Z minus 1, Z plus 1.
Awesome. Okay, so again, I'm going to combine steps. We're going to distribute. So here it's 2 times Z plus 1, meaning I get 2Z minus 2. You're right. Why do I have 2 over there? Yeah. So that's a minus. All right. Okay, so 2Z minus 2, then what? Minus Z minus 1, right? So a lot of this is bookkeeping. You don't want to lose sight of those negatives. Man. All right, equals to what? -2. I'm just testing you guys, right? Or not. Okay, so what do I get here?
Z minus 3.
Okay, and Z is equal to 1, but it can't be 1, so there is no solution. Do you see? So here we got Z is equal to 1, but Z is not allowed to equal 1. We cross it out, we're left with nothing, so there is no solution. Okay, so for no solution, we can write no solution, or we can do this. Either are acceptable. Okay? Yes? Now for the good stuff. Ooh, a weighted average. Okay? What does that mean, a weighted average?
One element minus 1.
Right. Exactly. So you've got like all sorts of different grades, right? You've got your grades for your tests, for your participation, for your homework, for your quizzes. I could either add all of them up and divide by the number of, homework and tests and, everything you've done all together. That would just be a straight average. That would mean that your participation grade and your homework grade and your quiz grade and your test grade all had equal weight. Or that's just a straight average. Or we could do a weighted average and say, okay, one category, the tests count for 50%, the quizzes count for this many percent, and so on and so forth. Okay, so that's what a weighted average means. Okay, so Jimmy is making a little concoction. Speaking of that math party, he adds 65% fruit juice solution to 15 milliliters of a drink that is 10% fruit juice. Okay? How much of the 65% solution must be added to create a fruit punch that is 35% fruit juice? Okay? What are we talking about? So he's got 15 milliliters of a drink. He's got 15 milliliters of a drink. And that 15 milliliters is 10% fruit juice. Okay? Now, he adds to this 65% fruit juice solution. Okay? And the question is, how much does he have to add so that the end result has 35% fruit juice? Does that make sense? Okay, so now the stuff in the container has 10% fruit juice. He wants to make it a little bit more fruit juice heavy. Okay? All right, so let's write this down. Okay, the original, right? The original has how much of juice? How much of fruit juice? Well, it's 15 milliliters. Well, let's just do 15. And that's at 0.10% fruit juice. Okay, 10% fruit juice. The total amount of solution is 15. Now, how much did this person add? They added a 65% solution, and they added X milliliters of it. So how much solution did they add? X. Okay, they added X amount. So if you like, the original has 15 milliliters of solution. How much of it is fruit juice? 10% of the 15 is fruit juice. This new one, you've added X amount of it. How much of that is fruit juice? 65% of that is fruit juice. Now, the new, all right, let's do the bottom row first. The new one, okay, the total solution is 15 milliliters plus X milliliters. And what's the concentration? It's 15 times 0.10 plus 0.65 X. Well, we're going to do that now. Okay? So, it says how much of this should be added to create a fruit punch that is 35% fruit juice. So let's just talk about this percentage of the juice to begin with, right? What is the percentage of the juice anyway? How do you calculate how much percentage of the juice there is? Well, it's the amount of juice over the total solution. Is that right? So if you have 100 milliliters and 10% of it is fruit juice, then, if you have 100 milliliters and 10 milliliters of that is fruit juice, how many percent is that? 10%, right? So that's how we calculate it. Right, so here's how we're going to do this. So the percent is 35%. We want the end result to be 35% fruit juice. So that's 35 over 100 equal to the amount of juice there is, 15 times 0.10 plus 0.65x over the total in milliliters is x. 15 plus x. Okay? Right. 35% is 35 over 100. You could have also done 0.35. It would have been the same. Okay? Right. So now, how are we going to solve this? We could cross multiply. That's the easiest. Or we do the same thing. Well, cross multiplying turns out to be easier here. So let's just cross multiply. So 35 times 15 plus x is equal to this one. How much is this? It's 1.5 plus 0.65x times 100. Right. So here we have 525 plus 35x is equal to 150 plus 65x. Okay? Subtracting 150 gives me 375 equals subtracting 35x gives me 30x. Divide by 30, divide by 30. X is 12.5. Okay? What were we looking for here? how much of the solution must be added to create the fruit punch? So it's 12.5 milliliters
Of 65.
of 65%. Okay? So, all right, so if you've got a boat and it's you're in a current, right? Let's say the boat is going at like 100 miles an hour, okay? And let's say there is a current that's at 20 miles an hour. If you're going with the current, the velocities, the speed just adds. It's a straight addition. 100 plus 20, you have a new speed of 120, okay? And if you're going against the current, it subtracts. 100 minus 20, 80. Does that make sense? Okay? It's really that simple, like the background of it. So now, take a look at this problem. The speed of the wind is 20 miles an hour, all right? So this is the wind, 20 miles an hour. It takes a plane 7 hours to fly 2,368 miles, round trip. And now it's asking us to determine the plane's, there's an apostrophe missing, the plane's speed in still air. Okay? All right. So what we want is the plane's speed in still air. We're going to call that R for the rate of the plane and to be consistent with the book. Okay. So let's just do a little bit of background. Speed is distance over time. Okay? That means this double arrow, or that arrow means that implies that what's the time? What's the t equals the speed over the time, right? I'm sorry, over the distance. What's the time? Nope. It's distance over speed. So, in other words, T is D over R. Okay? Yeah. How to solve this problem? Yeah, you do see them over there, and we're seeing it now here. Okay. Yeah.
The speed of the wind be canceled out. If it's round trip one way,
Well, but we want to find the plane's speed, right? So we need to find, yeah, you're right. But we need to find the value. That is. You're gonna see now how it's gonna be. Okay, so with the wind, the speed of the plane is R plus 20, okay? Because it's the speed of the airplane plus that of the wind. Against the wind, it's R minus 20. All right, so now let's make a little table for ourselves. So here we're going to have time with the wind. Here we're going to have time against the wind. And here we're going to have total time. Okay, what's the total time? How long does it take? 7 hours. So that's an easy one. Okay, now the time with the wind is going to be the distance he traveled divided by the speed with the wind. How much did he travel? How many miles did he travel with the wind and how many miles against the wind? It's half, right? So half of 2,368 is 1,184 each way. Okay? Questions? Okay, so here, time is distance over the speed. So with the wind, the distance was 1,184 over r plus 20. And against the wind, it's 1,184 over r minus 20. Okay? So the first one is an expression of the time he took traveling with the wind, and then the time he took traveling against the wind. Okay, when you add those two together, you're supposed to get 7. So 1184 over r plus 20 is equal to plus 1184 over r minus 20 equals 7. Okay, now we're going to multiply by the common denominator, which is r plus 20, r minus 20. Yeah, I mean, is the speed of the plane really going to be 20? It's never going to come out to be 20 anyway, right? Yeah. Okay, so take a look here. Okay, so these cancel. Okay, so what I have here is, I'm just going to distribute. So it'll be 1184 minus 20 times 1184 plus, oh, I'm sorry, 1184R plus 1184R minus 236 plus 23680 equals 7 times r squared minus 400. And here, these two cancel, like Mikey was saying. And now, what happens here? You have 2,368 r equal to 7r squared minus 2,800. Now let me just bring everything to the same side. This will be 7r squared minus 2,368r minus 2,800 equal to 0. Now, at this point, you can either factor and get the answers that way, or in this case, it doesn't factor. So let's see what we're going to do here. Let's use our calculator. We're going to plug this in. Yeah. So let's plug this in the calculator. So huh? Mm-hmm. What do you mean? Yeah. Yeah. 2368x minus 2,800. Now, if I just graph this, zoom 6, I don't see anything, right? Because what's the x-axis stand for? That's my r, right? And the speed of the plane is going to be somewhere in the hundreds, right? But this goes only up to 10. So what I have to do is go to window. So remember, x is our speed. Can I have negative speed? No. So I'm going to go from 0 to about, let's say, 400. Graph. Okay, so look, there we have a place where it crosses the x-axis. So let's figure out where that is. So look, I can do second calc. I need to find the 0. Okay? left bound, enter, and now I press the right button until we pass the cursor. You sort of have to, you can do it in the table too. Look for a y value that's 0. Okay, here we went to positive y values. Enter. So look, you have a 0 when x equals 339.5. So I say R is 339.5 and it's miles per hour. Okay? Let's move on to solving rational inequalities. Rational inequalities are where you don't have an equal sign, but you have an inequality. So what we're going to do, again, is we're going to state the excluded values or the restrictions. We're going to solve the inequality as if it were an equation, multiplying by the LCD, But then we want a range of values. We don't want just one value for the inequalities. We want a range of values that make the inequality true. So we're going to use the values to divide a number line into intervals. And then we're going to test the value in each interval. Okay, so let's just do this first one. What's the LCD here? 9x. So I multiply by 9x. Here I have 3 times 4 plus 7 times 9 is less than 5x. Right? So for a minute, for a very tiny minute, I sort of make that an equal sign just to make it easier for me to solve. So how much will that be? 7 times 9 plus 12? 75 is equal to 5x, and what's x? X is equal to 15. Okay, now, what was the restriction for this problem? X can't be 0. Now, what I'm going to do is this. I'm going to set up a number line, and I'm going to put on the number line 2 things. One is values that I got from the equation, so 15. 2, my restrictions. Okay, so I put values from the equation, and I put the restrictions. Now I need to test a point from each of the regions. How many regions have I divided the number line into? 3. Okay, so I'm going to rewrite my equation, my inequality here, 4 over 3x plus 7 over x, and I'm going to move everything to the left side. So it's minus 5 over 9 less than 0. All right, I'm going to test points to see in each case, am I going to get a positive or a negative value? Okay, so in the first region here, in region number 1, what value do you guys want to pick? Okay, -1. So if I put -1 into that equation, right, I get -4 over 3 minus 7 over 1 minus 5 over 9. Is that going to give me a positive or a negative answer? Negative. I really don't care what the value is. All I care is that it's negative. So I put a minus there. Okay, between 0 and 15, let's pick another number. What number can we pick? 3. How about we pick 1? Let's pick 1, just so we get a whole number there. So 4 over 3 plus 7 minus 5 over 9. Is that going to be a whole number? I mean, is that going to be a positive or a negative answer? Positive, so that's going to be positive. And what if I pick a region from, a number from region 3? What? 16, sure. So basically it's going to be 4 over 3 times 16, I don't care what number that is, plus 7 over 16, minus 5 over 9. So what do you think? Is that going to be positive or negative? I'm thinking negative. You can always check on your calculator. Always check on your calculator. So it's going to be negative. Now, it's very, yeah, the ones before are smaller. Okay, so now, my inequality here says I want numbers that are less than 0. Those are the negatives. So I want the region here. That's where I got negative values. And I want the region here. That's where I got negative values. How can I describe that region? Well, the one on the left is the region where x is less than 0. Or the one on the right is the region where x is greater than 15. And that's my answer. Okay? Right, so here we're going to multiply 4x minus 3, x plus 4. Okay, the 4's go away. The x minus 3's will go away, and so will the x plus 4's. So here I get 3 times x squared plus x minus 12 minus, I'm going to distribute 4x minus 16 is greater than 4x plus 12. 4x squared minus 12x. Okay, I'm distributing. So here I get 3x squared plus 3x minus 36 minus 4x minus 16 is greater than 4x squared minus 12x. Okay. And remember how I said we could change that to an equal sign? Right, because we want the values that where these equal 0 to put on the number line. Okay? All right, and we don't want to deal with like changing symbols and stuff. So, all right, so what are we going to get here? Negative x squared. So here I have 3x minus 4x is minus x plus 12x is plus 11x. Negative 36 minus 16 is what? So x squared, if I take out the negative, minus 11x plus 52 is equal to 0. Does that factor? Three and 14? No. Try to factor this. We couldn't factor it. We plug it in. When you graph it, you realize there is no value of where this equals 0. It's a parabola that sits above the x-axis, right? So it's never going to equal 0. So what does that mean? Does that mean I have nothing to put on my number line? No, because on the number line, I put the values I got from here plus the restrictions. What are the restrictions? Negative 4 and positive 3, right? Yes? So now I'm going to test points one more time. So let me rewrite the equation, the inequality here. Greater than 0. Okay, so let's choose a test point. Let's go smack in the middle and pick 0. Okay, because we like that one. So region 2, let's pick 0. I'm going to get 3 over 4 minus 1 over negative 3, so plus 1 over 3. And here, it's going to be 0 over 4, which is 0. So will that be positive or negative? Positive. Now, I'll tell you a little secret if you promise to not tell anybody, ever. Once, okay, if in the denominator, none of the terms have something quantity squared, if you don't have x minus 3 squared, x squared, okay? Then these here the pluses and the minuses will always alternate. So since here none of them are being squared, then I could alternate them and I say, oh, it's minus plus minus. All you need is 1, and then you could just alternate. And if you don't believe me, you could try it out, but trust me, I'm right. Okay? Now, do I want the positive or the negative regions? Try again. Positive, because this is greater than 0. So that's the region between -4 and 3. Okay? And one last thing. If the inequality here had a greater than or equal to, then these would be less than or equal to or greater than or equal to. Do you see what I mean? So it has to be consistent. Okay.